Hello and welcome. We will discuss PYQs of ratio and proportion in this video, and our theme is mixture and elevation. Let's solve some problem of this theme. It says there is a milk sample with 50% water in it. 50% meaningly half. If 20 liter sample is present, then half of 20, that is 10 liter in that will be water and the remaining 10 will be milk. If 1/3 of this milk is added to equal amount of pure milk, then water in the new mixture fall down to percentages are given. Let's say total sample available is 150 liter. Now, what is 1/3 of 150? 1/3 of 150 is 50 liter. So, if we have 50 liter sample, then in this 50 liter, half will be water. So what is half of 50? 25 liter in it will be water. And remaining 25 liter will be milk. Now, what has happened? 1/3 of this milk is added. 1/3 of sample, total sample was 150. So 1/3 of sample, that is 50 liter of sample, is added to equal amount of pure milk. So 50 liter of sample is added to equal amount of pure milk, that is 50 liter of milk, 50 liter of pure milk. So total mixture now will become 100 liter. Now if you pay attention to this equation formed carefully, you will find out this is the 50 liter of sample. In 50 liter of sample, we have 25 liter water and 25 liter milk. And then this 50 liter of pure milk. Okay. So in the new mixture, only 25 liter water is present and 25 plus 50, 75 liter milk is present. So what is the percentage of water? Total mixture now is 100. And in this 100, only 25 liter water is present. So in this 100, only 25 liter water is present. So water percentage will be quantity of water available divided by total quantity of mixture into 100, which comes out to be equal to 25%. So the water in new mixture will fall down to what? 25%. Option A is the valid answer here. Kindly make a note. 25% is the valid answer here. Kindly make a note. I hope guys this is clear to everyone, huh? Now we can solve this question with the help of allegation also. So we are having a sample. Okay, and in this sample 50% water is present. So in this sample we are adding pure milk. If we are having pure milk, then what can I say about percentage of water in that pure milk? If pure milk is present, then percentage of water in that should be 0. Now, when this sample and this pure milk is mixed, then we will have percentage of water in the mixture. Let's say in the mixture, percentage of water is X %. Now, as per allegation, x minus 0, x minus 0 is x only, 50 minus x. Diagonally across, we will subtract. X will be greater than 0, that is why x minus 0, and 50 will be greater than x, that is why 50 minus x. So as per allegation, this ratio of differences will be equal to ratio in which sample and pure milk is mixed. It is given that 1/3 of this sample and equal amount. So amount of sample taken and pure milk is same. If 1/3 sample is taken, so 1/3 milk should be added. So what is 1/3 is to 1/3? It is 1:1 simple. What it is? It is 1:1 simply. Equal quantity of sample and pure mixture has been added, so ratio is 1:1. Which means if ratio, so which means x upon 50 minus x should be equal to 1/1. I will attach these percentages in the later half. 1/1. So if we solve this further, it becomes x equal to 50 minus x, and if you solve it for x, it becomes 25. So what is the percentage of water in the new mixture? Percentage of water in the new mixture will be what? 25%. Hence option A is the right choice. What is this? This is your allegation. Okay, let's move on to the next problem now. Can I erase? Let's solve the next problem. This question says two equal glasses of same type, respectively 1/3 and 1/4 full of milk. They are then filled up with water. Okay, now let's try to understand. This question can be solved with the help of two techniques. One, the normal, another is allegation. Let me tell you both of those techniques one by one. So let's say capacity of glass 1 is equals to glass 2 is equals to 12 liter. I have assumed capacity of both the glasses to be 12 liter. Why? Because it is written here equal glasses, same type, and it is 1/3. In the denominator we are having 3 here, in the denominator we are having 4 here. So what is the LCM of 3 and 4? Assume 12 liter. Your calculation will become easier now. Now in glass 1, let's talk about glass 1. So in glass 1, 1/3 milk was present. So 1/3 milk was present. So 1/3 of 12 milk is present. They are then filled with water. So what is 1/3 of 12? 1/3 of 12 is 4. So remaining should be water, because total is what? 12. Okay. So in glass 1, milk should be 1/3. Total capacity of glass is 12. So what is 1/3 of 12? 1/3 of 12 is 4. So remaining should be water, that is 8, because the remaining part of the glass is filled with water. Let's talk about glass 2 now. In glass 2, 1/4 is what? Milk. In glass 2, 1/4 is what? Milk. Okay. Now, so what is 1/4 of 12? It is 3. So remaining part of the glass should be filled with water. That is 9 part in that glass should be water, because 3 plus 9 is 12 and 4 plus 8 is 12. What is the ratio? Now, they are mixed in a pot. What is the ratio of milk and water in the pot? Now they have been mixed. Now I can add these ratios directly. Why? Because if you pay attention to glass 1, what is 4 plus 8? It is 12. What is 3 plus 9? It is 12. So I can add these ratios directly. Why? Because the hidden condition of the question got justified. Total of glass 1 is 12, total of glass 2 is 12. Okay, so add them. What is 4 plus 3? 7. What is 8 and 9? 17. So what is the ratio? What is the ratio of milk and water in that glass? Ratio of milk and water in the pot when they were mixed in the pot, the ratio is 7 is to 17. Kindly make a note of it. Kindly make a note of it. Okay. Now, this question can be solved with the help of alligation also. Now, listen. There is glass 1, there is glass 2. In the glass 1, milk is 1/3. In the glass 2, milk is 1/4. When they were mixed, I don't know what is the milk in the mixture. Let's say milk in the mixture is X. Now, 1/3 is the largest value because 1/3 is greater than 1/4. So, X minus 1/4 diagonally across. X minus 1/4 is 2. 1/3 minus X. Now, the glasses are of equal volume. So that is why the quantity of glass 1 to quantity of glass 2 will be 1:1. Now, X minus 1/4 divided by 1/3 minus X. This ratio of differences must be equal to ratio of quantity of glass 1 to glass 2. If we solve this further, it comes out to be equal to X minus 1/4, 1/3 minus X. Solving it further to 2X, 1/3 plus 1/4, 2X is equals to 7/12 and X is equals to 7/24. So fraction of milk is 7/24. Fraction of milk is 7/24. So in the final mixture, milk is to water. Milk is to water milk should be 7, and for water subtract these two, 24 minus 7. So if we solve this, it comes out to be equal to 7:17. So milk is to water will be what? Option A. Kindly make a note of it. Milk is to water will be 7:17. Okay guys, let's move on to the next problem now. Let's solve this problem with the help of alligation directly. It says two glasses of equal volume. Glass 1 is there and glass 2 is there. Are respectively half. What is half? Half is 50%. And 3/4. What is 3/4? 3/4, 3/4 is 75%. Filled with milk. So milk in glass 1. Milk in glass 1 is 50%. Milk in glass 2 is 75%. When these two glasses were mixed, they are then filled to the brim by adding water and their content are then poured into another vessel. When these two glasses are filled, I don't know what is the quantity of milk in the new mixture. What is the percentage of milk in the new mixture? Let's say it is X%. Now you can see 75 is the greater value. So 75 minus X. 75 will be the greatest value because 75 is greater than 50. So 75 minus X is to X minus 50. So this ratio should be equal to ratio of quantity taken. It is given to us that two glasses were of equal volume. So ratio of quantities of glass 1 and glass 2 should be 1:1. Which means if you solve this, which means 75 minus X upon 50 minus X. Sorry. 75 minus X upon X minus 50 must equal to 1:1, which means 75 minus X is equals to X minus 50. If we solve this, it becomes 2X is equals to 125, X equal to 62.5. So X is 62.5%. Now 62.5% is what? 62.5% is 3/8. Done. X represent milk in the mixture, because it was milk here, it was milk here, so X represent milk in the mixture, so 3 represent milk of the mixture. So milk in the mixture is 3. Total quantity of mixture, percentage gives total quantity. 8 is the total quantity, so 8 minus 3. 5 will be water in the mixture. So ratio of milk to water. What we are looking for, milk to water, it should be, I'm really sorry guys, just correct it. 62.5% is 5 by 8, not 3 by 8. So correct it. So milk in the mixture will be 5, and water, for water subtract these two, which is 3. So milk is to water in the mixture will be 5:3. Now guys, when we write down fraction or we write down ratios, we write down percentage, then the denominator represent total quantity. So if 8 is the total quantity, so out of 8, 5 is the milk, so remaining 8 minus 5, remaining should be what? Water. I hope guys this is clear to everyone. Okay, so this is all for the video. Thank you so much. Bye bye and take care.